another machine learning talk. And in particular, what I want to take a look at is automated ML techniques. And basically, I want to try and address the question, with automated ML, does that mean that we're all machine learning engineers? And we'll see by the end. The answer is no, it's not quite that simple. But the automated tools really are pretty powerful. So first, some quick background. I'm a principal engineer. I focus primarily on cloud and data technologies. I'm also an author, most recently, of 3 of the official Google study guides. And then also I have courses on Udemy and LinkedIn, mostly around cloud and data science, machine learning topics. So if you're familiar with cloud products and you've, say, maybe worked with any of the 3 major ones, you've probably come across or seen some mention about automated ML. Like in Google, they talk about, being able to do machine learning with minimal machine learning expertise. AWS goes even farther to say, it's machine learning for every developer, and Microsoft has similar kinds of things. And while this is really true, there's a lot that the automated ML techniques do for us. It doesn't actually cover the whole spectrum of things that we need to do in machine learning. And so what I'd like to do is kind of take a look at, first of all, the machine learning workflow. So where does this AutoML stuff fit in? And what's left over? What's not covered by AutoML that we still need to be able to basically handle on our own? So we'll start off with that. We'll look at how you go about, what's required to formulate a machine learning problem. And then I want to spend some time looking at services that are available in Google Cloud for building machine learning models. And we'll look at both automated tools and other tools that are more sort of build your own, do it yourself kind of machine learning tools. And then I also want to talk about services in GCP that are used for data engineering, because really that's the bulk of the work that isn't covered by AutoML. But there are a lot of services that we can use, so we'll take a look at those. And then finally, I want to take a look at monitoring machine learning models that are in production. And an increasingly important topic is evaluating fairness, because if we're going to start using algorithmic decision-making, we have to make sure our models comply with the same things we would expect a human to comply with. So let's take a look at formulating an ML problem. Basically, there is a machine learning workflow, and this is pretty standard. People seem to have adopted this pretty widely. The first is that we formulate the problem. So we have some kind of business problem or a question or a science problem that we're trying to deal with. And we have to make sure we can sort of frame that in a way that we can apply ML techniques. So this is, in some ways, this is one of the hardest problems. Another hard problem is identifying data sources. So we need to know where we're going to get our data, and also understanding what's the quality of the data. What do I need to get the data in a format where I can actually use it with an ML algorithm? Sorry, my dogs are going to join in here. Yeah, there's the second one joined in. Let's see, we're going to focus now. I'm kind of shifting gears. So the items in red are things that aren't really covered by automated ML, and the things that I'm bullet items in black are really the focus of automated ML tools. So training, evaluating, and tuning models, deploying a model to production, so just like deploying software in a CI/CD pipeline, and then using the model in production. And then finally, evaluating fairness really isn't covered by automated ML. Monitoring is somewhat, but there's probably more monitoring that you should be doing than is available in some of the automated tools. So how do we define the problem to be solved? Well, usually we start with some kind of informal description. Like if you work for an insurance company that sells health insurance, you might want to predict people who are in the hospital, maybe having, say, a hip replacement surgery or a knee replacement surgery. You want to be able to predict which of those patients, when they leave the hospital, are most likely to, say, fall and have to be readmitted to the hospital. And you want to know that because that, one, it's another injury to someone who's already had surgery, and two, it's going to cost you as the insurance company more money. So you want to be able to sort of formulate a problem in business terms at this level, and then leave the sort of technical ML stuff for later in the process. So one of the things you need to understand is what's the value of solving the problem. And I've seen this many times where engineers have really deep interest and deep understanding of ML algorithms and find a way to apply that or can see a way of applying that to a particular problem. And the only snag with that is that that particular problem that they may be looking at isn't really of much business value. So yes, it's interesting from a technical perspective, but not necessarily from a business perspective. So we want to watch out for that. And you want to think about how the problem can be solved. So in particular, we want to know, is this a regression problem? Do we want to predict a continuous value? So for example, do we want to predict the selling price of a house in a particular market? Or is it maybe a classification problem? So for example, you might want to identify, in a radiological image, is this an example of, say, a malignant tumor in an MRI image or an X-ray image? So those are classification problems and regression problems. Those are really probably, they cover a wide swath of the kinds of problems we take on in machine learning, and they're definitely the ones that are covered the best in automated ML tools. So another thing you have to do is basically identify data sources. And here, one of the problems is we sort of have almost too much of data available to choose from. So we have to be able to identify sources, and we want to understand certain characteristics of the data sources. So for example, we want to understand, what amount of data is available. And this is especially important when we're working with supervised machine learning algorithms, so regression or classification. Because in those cases, we need what's called labeled data. So we need to be able to understand what are examples of, say, something that has in a certain class and something that's not in a certain class. Or, we have, if we're doing a regression problem, the amount of the sales price of particular houses. So we need to understand what's the amount of data available, and is it sufficient, and is it high quality enough to allow us to actually build a model using the particular tools that we have available. We also want to think in terms of the rate of the generation of data. Is it very sort of sparsely generated data? We don't get a lot of new data. That's important to understand for things that we'll look at later. One of the things is, for example, is known as data skew. So if you build a model today with a certain set of data, maybe if over time, say patterns of behavior in your customers might change for some reason, you want to make sure that you have enough fresh data to be able to capture those changes in the model as well. And then another key thing to think about is, what are the requirements to get access to this data? So this is especially important if you're working with any kind of healthcare data or financial data or anything else that might be protected under certain kinds of government or industry regulations. And with those requirements to access, there may be limitations on the use of the data. So for example, if you collect data from your customers using mobile apps and you're collecting, say, geolocation data, there may be restrictions on what the customer has agreed to with regards to the data. So you want to make sure that, early on in your problem formulation stage, you're paying attention to that. So once we have the problem and we have a good understanding of what we're trying to do, then we can start thinking about, like, all right, what are the tools we can use to actually build a machine learning model? Now, GCP is a great platform for building models because there are so many options. So there's Cloud AutoML. There is an AI platform training, which allows you to use sort of standard tools that we often use in ML and run them in a sort of a managed environment. Kubeflow is a widely adopted machine learning pipeline that runs in the Kubernetes environment. We also have the option of using Cloud Dataproc, which is a managed Spark Hadoop platform. And Spark has a pretty rich machine learning library. And then also recently, BigQuery, the serverless data warehousing service, added machine learning capabilities into BigQuery SQL. Now, Cloud AutoML is really a great example of an automated machine learning tool. So it really is designed for model builders with limited ML experience. And it provides a GUI for actually managing all of the training, evaluating, and tuning processes. Now, included in Cloud ML are sort of sub-services which specialize on things like machine vision, language processing, and also working with structured data. The structured data one is called auto tables or AutoML tables. And literally, you can start with a sort of say a pandas data frame, an Excel spreadsheet, a table or view in SQL, and that can be your starting point. And AutoML can actually work with that and start developing regression and classification models for you. Yeah, so as I mentioned, it uses structured data to build these models, and that's as opposed to unstructured data like images, natural language text. But for unstructured data, there are these other specialized services. So the AI Platform Training Service basically allows you to train and run models that you build in commonly used machine learning tools like TensorFlow. Scikit-learn is a widely used Python library, and also XGBoost, which is available. You can access XGBoost through Scikit-learn. It is really one of the best, highest performing tools in a broad range of, or algorithms in a broad range of machine learning tasks. And TensorFlow, I'm sorry, I should have mentioned, is used for building deep learning models. Now, when you use the AI platform, you can use some pre-built frameworks and containers, but you can also run your own custom container as well. And basically what happens is with the AI platform training, the service will provision whatever sort of compute resources you need to run the job and actually keep the job executing. So this allows you to focus on the model and building the model and tuning the model, and less on sort of concerning yourself with, provisioning resources and, thinking about like scalability and how many containers you should be running. Kubeflow is a service that's used in Kubernetes. So if you're already working in a Kubernetes environment, this is a good option. And basically, it allows you to package your models like applications. So it really fits well with sort of the Kubernetes framework. And like with automated ML tools, with Kubeflow, you can compose, deploy, and manage the ML workflows. Now, I mentioned Dataproc, and again, that's a managed service, and it really was designed for allowing people to migrate their Hadoop or Spark clusters that might be on premise into Google Cloud. And now, Spark also has an ML machine library, which is really rich. It's been around for years, and it has a wide number of ML algorithms. It also has tools to support feature engineering. And feature engineering is one of those sort of processes in the sort of the broader data engineering task, where you basically work with your data to try and come up with features or attributes or columns in your table which show useful information from a machine learning perspective. It helps you discriminate across, say, classes, or it gives more information to the regression algorithm for building models. So sometimes we need to combine features, say take a ratio of two numbers or something like that. That's a kind of feature engineering. It also has pipelines. So if you're familiar with Spark, or you've been using Hadoop and you want to work in that environment, you can still build pipelines and manage large segments of your workflow within Cloud Dataproc. And you can persist your models, and also there are a variety of utilities for working with data. Now, one of the most interesting sort of features, at least from my perspective, with regards to machine learning in Google Cloud, is the introduction of machine learning libraries into BigQuery. Now, again, BigQuery is a serverless data warehouse service, and although it uses SQL, it's not a relational database. It's not like Cloud SQL or Cloud Spanner, which we use to build, say, transaction processing systems. BigQuery really is designed for sort of analytics, answering queries that maybe query a relatively small number of columns, but need to go collect that data from many, many rows. Also, it's not great for updating, like in terms of, once you write a row, typically in BigQuery, you don't update it. You're constantly adding data. So BigQuery, again, it's not a transaction processing system, but it does use SQL. And now we can use SQL functions to build machine learning models right in SQL. So if you're familiar with SQL and you want to build machine learning models and you happen to be working in sort of an analytics environment and you're working with BigQuery, definitely take a look. It's really easy to do. And some of the key advantages are you build and train the models right in BigQuery. You make calls using SQL functions. So you don't have to work in a different environment like scikit-learn or TensorFlow. And again, the other thing is you're using SQL. So if you're not familiar with Python or the other machine learning frameworks, you can still build a classification model or a regression model right in BigQuery. Okay, so those are the services. And now I'd like to shift gears and sort of talk more about sort of the high-level processes that are part of the machine learning workflow. And a big one, as I mentioned earlier, is data engineering. Now, one of the tools that Google provides for this is something called CloudComposer. And it's another managed service, and it's based on the Apache Airflow service. And basically what it does is it executes workflows that are defined as directed acyclic graphs. So I'll show an image in a second about more about that, about what that is. But the idea here is basically what we do is we specify like a whole series of events that we might need to do. For example, we might need to check and see if a file has been dropped into a cloud storage bucket. And then if it has been, then let's do some quality control checks to make sure it's meets certain characteristics, and then we do some pre-processing. Then we train our model or do some feature engineering, and so on and so on. Well, CloudComposer is a great tool for organizing all of that as a single unit and being able to manage those as a single unit. Now, like other GCP services, you can work through either the console or the command line. So here's an example of a workflow that's defined as a directed acyclic graph. So we have our starting event A. So that, again, that might be a file being dropped into cloud storage. And step B might be a quality control check to make sure the data is in the right format and structure. And then if it passes B, then a series of other tasks, C, E, and D, are executed. Now, before D can execute, maybe something else has to be in place, say G. So for example, another piece of data, say some reference data that you want to combine with B, has to be in place. And so when both of those are in place, then D can do a join, and then it'll produce output, which is combined with the output of B and C, which is processed by E. And then finally, E does something else and maybe wraps up the data and pushes some output or makes a prediction and pushes it out in step F. So all of those tasks, you can coordinate, you can run, say, using cloud functions and trigger one after the other. But one of the nice things about using Airflow is that there are a lot of sort of process controls already built in. So for example, if you have to wait on something, it's very easy to specify how to wait. Or if a task fails, you can easily specify how many times to retie before failing the entire workload. Now, when you specify a DAG, it's basically a specification or a script, and it's stored in cloud storage. And there are a lot of plugins and operators so that you can work with different kinds of tools like different databases, or you can run a command on a bash shell script. And Airflow is also based on Python. So it also works with Python dependencies. So if you have to import packages and things like that, it's fairly easy to do. So here is an example DAG specification. Again, this is in Python, and if you're not familiar with Python, but you are going to be working a lot with machine learning, then I would really encourage you to learn some basic Python. You don't have to be an expert by any means. Even some basic just scripting knowledge, being able to do a minimal sequence of steps and maybe some conditional logic, just really basic programming. A little knowledge of that in Python goes a long way in machine learning. And not only would you be able to say, for example, to specify the DAGs, if you have to step into other programs like scikit-learn or TensorFlow, then you can use Python with those as well. So it's definitely worth looking into Python. Now, CloudComposer works with the idea of environments, and they're basically a set of services that are run within Kubernetes engine. And it uses a combination of what are known as tenant and customer project resources. And so here is a sort of a diagram of the CloudComposer architecture. And over in the sort of the blue section on the left is the customer project. And those are things that are resources that run in your project. Then there's also a set of services that are actually managed by Google. So they're not really, managed by you at all, but this is part of more part of the managed service. This. So there's two components. Just again, and I mentioned this only as you dig into CloudComposer and you start hearing about tenant projects. The key thing to remember about that is that's stuff that's strictly managed by Google and not something that you necessarily really have to. Cloud Data Fusion is another tool you may want to use for data engineering tasks. And Cloud Data Fusion is, again, it's a managed service, and it's based on another open source tool. And basically, it's an ETL or ELT development tool. And ETL stands for extraction, transformation, and load. And ELT is just a switch of that, of extraction, load, transform. And the idea here is that a lot of times we're pulling data out of source systems. So the data sources might be cloud storage, it might be a Cloud SQL database, could be a NoSQL database like Bigtable. And so pulling data out of databases and then doing some operations on them, sort of cleaning them up, reformatting them, transforming the data, that's a very common task. And it's really nice if you have something like a code-free ETL tool, because it saves you time. Now, Cloud Data Fusion has a large number of connectors, which allow us to get the data, and a large number of transformations, which allow us to manipulate the data. So, for example, you can reformat data, change the structure or the way dates are formatted pretty easily. And it uses a sort of a GUI environment. So we have drag and drop construction. Now, that's sort of what the tool is like in terms of how it's deployed. It's deployed as an instance. Now, there are two editions. There's the basic, which has a visual designer. It has the transformations. You can work with SDKs. And then there's also an enterprise version, which has all of those things. Plus, you can do things like capture streaming data in pipelines. You have tighter integration with metadata repositories, and you have high availability features as well. So Basic is a great one to sort of get started with. So if you're learning, definitely take a look at that. If you're using it in production, or if you need to be able to work with, say, streaming data, then you probably want to take a look at the Enterprise Edition there. So here's just an example of the Cloud Data Fusion visual interface. And if you've ever worked with other ETL tools, this probably looks like a very familiar format where you have a palette on one side, and within the palette you have things like connectors to sources, or you have sort of common transformations that you might apply to certain different data types. And it's basically a drag and drop, and then connecting between components, and then specifying say operations like what are the inputs and outputs and things like that. So once we've sort of formulated our model, built our model, have our services up and running, and have gone through all of the sort of the data engineering work, then sort of one last piece we need to do once a machine learning model is deployed is, or even before deploying, we want to be able to monitor it. We have to set up and understand what are the performance characteristics of the model. And really there's two types of monitoring that we're doing. There's sort of the application specific, how are we doing from a resource utilization perspective? What is the responsiveness of the model? What's the latency in making predictions? There's that kind of operational monitoring. And then there's also the monitoring in terms of the quality of the decision-making or the predictions that are being made. And again, fairness is a particularly important topic on that front. So with monitoring, our objective is to understand the performance of the model. So this is just very similar to understanding any application performance. So there are certain metrics we want to monitor. So we want to, for example, look at traffic patterns. Are we getting more data from some sources than others? Error rates. So is the model failing? Are we getting, say, error rates, especially in our ETL or quality control checks? We also want to understand latency. So how long does it take to, say, return a prediction? Or we also want to look at, say, what's the latency of extracting data, say, from a cloud storage or from a database. If the latency is increasing, that could be indicative of a problem. Now, sometimes latency problems, for example, with making a prediction, it could be a problem with the model. The model isn't performing very well. Or it could be latency in a data engineering task, like extracting data from a database. And if that's the case, then we might have to, say, look at some SQL queries and see if we need to tune those to increase the efficiency and the performance of those queries. We also want to understand resource utilization because cloud resources are typically, allocates and pay for what you allocate. We want to make sure that we're getting, efficient use of our resources. And we don't want to over-provision and we don't want to under-provision. So metrics that help us understand resource utilization are really useful. And we also want to be able to say, for example, to configure alerts in cloud monitoring. So cloud monitoring is one of the services that used to be a member of what used to be called, Stackdriver. Almost forgot that there for a minute. And Stackdriver has been broken up, and now it's called like cloud monitoring, cloud logging, cloud trace, and so on. Now, one of the things about cloud monitoring is you can create alerts. So if you're familiar with things like Prometheus or Datadog, cloud monitoring does similar kinds of things. You can specify metrics and thresholds, and say your CPU utilization goes over 80%, you can get an alert or have it trigger an alert and let you know that you need to take a look at that. So just as you do these kinds of things with regards to monitoring with other applications, you want to think about how you can do them with your machine learning models as well. Now, AI platform, for example, can export metrics to cloud monitoring, which makes it really easy to just use the cloud monitoring interface to be able to look at metrics and also set up alerts. And we can get things like error counts, the latencies I mentioned. Oh, accelerator utilization. So in addition to say, looking at CPU utilization, oftentimes with machine learning, because there's so much math that's going on behind the scenes, especially in the training phase, we often want to use, say, maybe a graphics processor, a GPU, or a specialized accelerator which Google developed, which is called a tensor processing unit, or TPU. And so those are additional resources that we can add, say, to our instances or to our containers. And when we do that, we want to make sure that we're using them efficiently. And you may not be able to tell just by the behavior of your model. So getting metrics on accelerator utilization is really helpful as well. And then, of course, there's other sort of standard metrics like memory utilization, CPU utilization. We want to make sure we track those. And also networking utilization. Oh, I mentioned latencies earlier. Of course, a network can also be a cause of latency as well. So you want to watch for that. Oh, and then there's some sort of ML sort of specific metrics that we can get out of the AI platform. For example, how many predictions have been made in the last minute or hour? So we can understand what's the, how are other services using the models that we've deployed. Now, some best practices. We want to monitor for data skew. And again, I mentioned that briefly in the beginning of this talk. Data patterns can change over time, and sometimes they're cyclical. So for example, say you're an e-commerce site and you're noticing certain buying patterns, and they may, say, change by the season. So people will buy certain types of products in the spring or the summer, but shift away from those and buy different ones in the, say, fall and winter. Well, if you build a model using data that's based solely on spring and summer, then it's probably not going to work so well when you start hitting the colder months. So what that shift in data across, say, the entire data set that you work with and over extended periods of time is known as data skew. So you want to make sure you monitor for that. Is your data changing? You also want to watch for changes in dependencies in your workflow model. So you may have upstream dependencies, like you depend on, say, an application or an app that's generating data and it's writing data, say, to cloud storage. Well, what if the developers of those applications decide, oh, we want to start using Cloud Firestore instead of cloud storage because we want, a lot of the benefits that come with using Firestore? Well, that's going to change some of your ETL processes or ELT processes. So you want to make sure that you have a way of detecting changes in upstream dependencies that might affect you. Also, you want to make sure that models are refreshed as needed. And this really will vary. Some things, again, like consumer purchasing patterns may change fairly frequently, while other things like, say you're in a scientific domain and you're, say, developing models for categorizing radiological images, that might not change as much. The models may be fairly stable over extended periods of time. So you just want to understand, like in terms of your own domain, how frequently the models should be refreshed. And then a really important best practice with regard to modeling is sort of assessing the model prediction quality. So when it's in production, you have to really, as best as you can, try and get a sense of how well are you making predictions. This is especially useful. So if you're predicting whether or not say a transaction is fraudulent, say a credit card transaction is fraudulent, you'll be able to know, like say, in a short period of time, whether or not a prediction was accurate or not. So you want to be able to use that data to determine, how well your model is performing, and you need to go back and say maybe do some more feature engineering or tune the model in some way. And then a really important one is, again, testing for unfairness. Now, fairness is a kind of in a lot of ways, it's it's an ancient concept with regards to machine learning. It's fairly new in the last several years, and it's basically the idea that we want our models not to be biased, and not a bias is a little bit of an overloaded term. Like in machine learning, you often hear the term or the terms bias and variance. And that has a specific meaning within machine learning. But people typically use the word fairness instead of bias when we're talking about, are we biased in the predictions we make? And there's two ways of thinking about bias. One is, fairness. Sometimes we think in terms of statistical patterns. So for example, if we're making decisions about who to give a mortgage to, and we have two subgroup populations, A and B, we would expect to get the same sort of predictive quality and measures of, say, false positives, false negatives across both A and B. If we, say, have more false negatives in the B category, then we're not really being fair. So we want to be able to watch for that. So that's at a statistical level, and that's one way to define fairness. Another way to define fairness is at an individual level. So rather than looking at a broad category, we look at, say, two individuals, say two customers, and if they're very similar, then the general idea is they should be treated similarly. And so there's a lot of research going on in fairness research, and when you should use statistical models and when to use individual models, and how do you measure fairness across all of those. So it's a really active area of research. So what I just want to cover today is just first introduce the topic, and then introduce some ways that we can sort of work toward improving the fairness of our models. Now, one technique is called anti-classification. And basically, it's a really simple idea, but basically we just protect certain attributes and we don't use them in the model. So for example, gender, if we're making, credit decisions, then gender really shouldn't be a factor. So, why use it in the model? Why use that in the training data or the evaluation data? So if we exclude certain attributes, that's an example of anti-classification. Now, classification parity is an example I mentioned. So this is the idea of that statistical fairness, like you have 2 subgroups or 3 subgroups or n subgroups. You want to make sure the performance is relatively the same across all of the groups. And then there's also this idea of calibration. So as you're making predictions, you want to make sure that the outcomes are independent of predicted attributes or protected attributes. So for example, if you're making credit decisions and you're finding that you're denying credit to a certain subgroup more than you would expect, say we're working with gender and there's a certain gender category that you are denying more often than others. Now this can happen even if you're excluding gender, because there may be other data attributes in your data set that highly correlate with gender. So even though we exclude the one attribute, there's other pieces of information that highly correlate with gender, and maybe for some reason we have a bias or we're unfairly using those correlated attributes. So calibration is a way to detect that kind of unfairness. Now, it's such an important topic that I just want to point out some resources. There's Google Machine Learning Fairness has a great description, and here's a link to that. IBM's also done research, and they have some information and tools. Fair ML is an open source tool for doing sort of interactive fairness evaluation of your models. And Google also has a what if tool, which again is an open source tool which you can get on, is available on GitHub. So I just want to kind of wrap up. That was a kind of a quick overview of machine learning and this idea about automated ML. As you can, I hope you can see from this point of view that there's a lot more to machine learning than just running some data through a training algorithm. So the key takeaways are that machine learning workflows, they're really multi-step, that automated ML addresses some, but not all of the steps, and that at the end of the day, there's still a lot of data engineering and other work like ETL work and monitoring that's still required. So with that, I'm going to wrap up, and I would be happy to take any questions. And also feel free to connect with me afterwards if you have questions. I'm on LinkedIn at Dan Sullivan PDX, so feel free to message me or connect anytime. Thank you. Stop sharing.
All right, thank you very much, Dan, for your talk. If anyone has any questions, they should just put them into the question and answer section on the site. I'm seeing that we've got a few in here. Dan, first of all, thank you. So we have one from Karen Unknown. Kubeflow package models like an application. Is it like a Docker image?
Yes, it's a container, right? Everything gets containerized. So yes, basically what you're doing is taking your model and treating it like really any other piece of software that you want to put, say, into a Docker image.
All right, do we have any other questions for Dan?
No. Okay. Well, again, if you think of questions afterwards, feel free to message me. I'm always happy to take questions and talk about this. Great. Well, thank you.
All right. Well, everyone, so that was Dan. He was our final speaker of the day. Dan, if you want to just pop off the stage. All right. So, unfortunately, everyone, this does bring us to the end of DevFest Northeast 2020. It's been a long and interesting day. We've had technical hiccups, and now it's for the part you all really are here for, the prizes. So before I anything else, I want to thank everybody for showing up today. I know times are tough and it is Halloween, but I hope you all enjoy things. I want to thank our sponsors, which you'll see over here. So that's people like JetBrains, TechMakers, Gaspacio, Developer, I Am Remarkable, Practicum, New York Tech Loop, ROI Training, and Wellframe. And also O'Reilly, but apparently O'Reilly is stuck in the shadow world because their logo is coming through as just a black box. No idea why that is. Of course, also we want to thank GDG Platform for getting us all here. Put chat so I can see if people are talking at me. For anyone who, actually, no, you all know what the GDG is. You're here. It's Google Developers Group. We're a community-driven bunch of people trying to serve our communities with interesting tech talks and community-based events. So for the raffle today, we're going to just go over how it works real quick and then I'll put the link up. The way the raffle works, you in a few moments will see over here a QR code and a URL. They both go to the same place. It goes to a Google form. Put in your name, your email address, and the phrase for today, technical difficulties. By doing that, we will know you are sitting here listening to this stream. Then we're going to spin a wheel and give away prizes. We have a lot of prizes to give away, about 30, I want to say 38. I know I'm probably forgetting a few. That's because we have so many prizes. Okay. Oh, look at that. We've got all sorts of thanks for Dan. And again, thank you, Dan. Your talk was wonderful to have. It's always great to find new and interesting ways to deal with data science without having to fire up, well, the entire data science cluster. All right, and with that, I'm going to be transitioning over to the QR code in 3, 2, 1. Magical transition. There we go. That is the QR code and the form for this raffle. Just take and go there. Either scan with your phone, use Google Lens, use some artificial intelligence right here, right now. Okay. So the URL is on screen. All right. Somebody will also paste the URL. There we go. Linda just pasted the URL. Everyone, remember, you need your name, your email address, so we can actually, send it to you. Well, you can't just send it by owl or mail or telepathy. Although, hold on, let's try. It is Halloween. Let's try some telepathy. Nah, it didn't work. All right. So, name, email address, and finally, the secret phrase today, which was technical difficulties. Remember, technical difficulties. And we're going to give everyone, say, 10 minutes to fill that out. But don't feel bad if you don't win anything, because everyone who shows up today is getting a 1-month access to O'Reilly books. That's right, 30 days of access to O'Reilly books. Just go to the link that Linda will be pasting in chat in just a moment and use the code DevFest20 to start with your free trial. Rebecca, you were asking, the passphrase is not case sensitive or space sensitive at all. Or spelling. If your spelling is bad, that's okay. I cannot spell. In fact, if you can't spell, that's a wonderful technical difficulty. Yeah, apparently O'Reilly didn't want to show up on the logo form. They want to stay in the Shadowverse, but they are caring about us. And we all love books. Although I would like to get out of this box I'm stuck in, because it's very small. Small box. Small, tiny little box I live in. Step back. We're using the most sophisticated AI on the planet. I'm seeing some bad puns in chat. just going to take and go in and check to see who's filling out this form. Wow, I'm seeing all sorts of people are filling out the form. Wow, thank you very much, everyone. It's really nice. We've got 86 people. Wow, 86 people. All right, I'm actually getting a message from the outside world, outside my blue box that I'm stuck in, that we have some winners from the earlier practicum slides. So, for the web developer course, we have Gabriela. I'm going to spell your last name because I have a complicated last name. I'm not going to try to pronounce it. Baranciuc. Just shout out in chat or send a direct message to Linda saying that you are here so that we can make sure that gets over to you. All right. For the data science course, we have Jared. Please ping Linda, say you're here. And for data analysis, we have, oh, wow, I thought I had our name. ANGGAAGIA. Again, ping Linda and tell them you're here. Just so you know, my name is Rainer Pasquis. I have a complicated name too. I feel your pain of having a long and interesting name. All right, I'm seeing some people, unfortunately, filling it out with DevFest 20 as the form name. Well, you're definitely paying attention, even though that's not the right thing, so don't worry about it. All right, then we're going to let this run for another. Let's see. We've got almost 100 people in here. That's pretty nice. And Linda, she's saying congratulations. You guys like this blue box? Should I stay? I don't know. The blue box is nice. It's better than most apartments in the valley. All right, Mark, if you look at the screen, you'll see the URL or QR code. I want to use your name, your email address, which I hope you have, and the passphrase for today. Today's passphrase is technical difficulties. Technical difficulties. All right, so we're going to take and run this for another 5 minutes. I'm going to set my watch here for 5 minutes. I'm seeing some interesting things happening in chat. The tech, yeah, we are having the techiest of difficulties. Of course, by saying that now, watch, my camera's going to die. It didn't die. Okay, we're getting a little bit better off. So, in another 4 minutes, on the screen right here next to me, where you guys see the QR code and link, you will see a wheel that will spin. And with that spinning wheel, we will find out who wins what. And I'm seeing more and more people still filling out that form. Wow. Remember, you have another 3 minutes. That's right, 3 more minutes until you too could win something here at DevFest Northeast 2020. Just got to check your chat, see what everyone's saying. And Linda's calling out in chat some more people who win the practicum prizes. Just shy of 100 people in the raffle. That is pretty impressive. I hear people asking for the O'Reilly, how to sign up for it. So there will be, everyone gets everyone who attended today will be getting a free O'Reilly code. The code is DevFest20, and Linda will hopefully post the URL in just a second. If not, I will jump out of frame and type that in for y'all. If everyone wants to know my costume is someone who isn't having technical difficulties. All right, let's check that timer. We have just over 1.5 minutes, 1.5 minutes until the raffle closes and we start spinning the wheel. Oh, and seeing some more people filling out the form. We have broken the 100 people mark. Wow, I am really thankful that you all showed up today. Yes, the coupon code for O'Reilly is DevFest20. The URL for O'Reilly should be in chat relatively soon. Can't stand that far back. There you go. And if you all look in chat, you'll see a message from Linda. The URL for O'Reilly is o'reilly.com/get-learning, code DevFest20. Again, that's o'reilly.com/get-learning, code DevFest20. All right, everyone. And that right there means we're going to close our raffle. Just give me a few seconds to work some magic. Some Halloween magic. Oh, wow, that's a lot of names. Okay. Hope everyone's ready for some really fun things. All right, so you all can see this. See the link? Can you all see it? Slowly spinning names. Slowly spinning names. All right. So just gonna pull up my handy list of everything that we're giving out today, which is a lot of stuff. I mean, I just, oh boy. Okay. So to start things off, we're gonna give out a free O'Reilly book. And for first O'Reilly book, spin the list. And we're spinning. Wei Yu, Yao, I'm not sorry if I'm butchering names. You are the first winner of our raffle. You will be getting an email later on today, tomorrow, sometime around that, to take and claim your prize. Okay, it's one O'Reilly book. Giving out a full 10 books. So for the second O'Reilly book, Spin, spin, magic wheel. Amy Lamb, you are getting a book from O'Reilly. Again, we all know that there's no way for us to figure out how or what wins for book covers. Game reports that people aren't seeing who won. Oh, sorry about that, everyone. Technical difficulties are technical difficulties. Can everyone see the wheel? I'm going to wait a second until I get confirmation from chat that you all can see the wheel. Everybody see the wheel. So far we've had 2 people win. If you could. All right. Next winner. Glenmo Martin. Glenmo, congratulations. You get the 3rd O'Reilly book. So Amy Lamb, Way, Glenmo, you guys are getting books. Congratulations. Now, the 4th book, actually. 4th book. I'm going to count properly. Control. Enter. Spin, spin, magic wheel. And your name moved too quick, Andres. I'm sorry. I didn't get your last name. You're getting a book. Another book. That's 4 books. This is our 5th book. Wow, getting out a lot. We should be a library. We're getting out books. There we go. Spin, spin, spin. Our 5th book, people. Sukat, I'm not going to try to pronounce your name. I'm sorry. You're getting an O'Reilly book. Getting some information. Apparently, people can't see the wheel. So, fortunately, you're all going to not be able to see my wonderful face. So we can see the wheel better. So this is our 6th book. Our 6th book. M. Gundel. M. Gundel, you are getting an O'Reilly book. And yes, I am counting on my fingers. Check in with next one. 7. Number 7. Magic number 7. For our 7th O'Reilly book. Margaret Harrison, you are getting an O'Reilly book. Can I suggest a good one? Oh, what am I talking about? They're all good. Number 8. Who will be number 8? Karen, you are getting an O'Reilly book. All right, now for our 9th O'Reilly book. Gabriella, your last name flew by too fast. Sorry. But you're getting a book. Hope that makes it better. And for our last O'Reilly book of the day. Mama, your last name was so big it couldn't spell it out. You are winning a book today. All right, that's our 10 books. And just a reminder to everyone in channel, if you showed up today, if you can hear the sound of my voice, then you qualify for 33 days at O'Reilly Books. O'Reilly.com/get-learning. Use the offer code DevFest20. Again, that's offer code DevFest20. All right, so, well, before giving out our wonderful sponsors, now ROI Training. That's right, our next sponsor is ROI Training. We have giving away 4 certification training classes for them, plus 10 $50 Google Play gift cards. So let's start off with the 4 on-demand training classes from ROI Training. So the first ROI Training winner is spin, spin, spin wheel. Jared, you don't have a last name, so hopefully there's only one Jared. Jared, you are getting one of the ROI Training courses on demand. For our next ROI Training course, that name was back. I'm trying to read it backwards in my own stream. You are winning an ROI Training course. We have 2 more training courses to give out, everyone. 2 more. All right. This is for our 3rd ROI Training course. Sutarao, you are getting an ROI Training course. Tandu Tran, I hope I didn't get your name wrong. If I am, I apologize. You are getting an ROI Training course. You know what? Because I'm definitely butchering people's names, I give everyone in this channel permission to butcher my name. If you see me at a conference, on the street, at the job, butcher my name horribly. That way, we're all in this together. All right, we're going to take a quick 1-minute break while I confer with everyone backstage and make sure that we're not getting things out to everyone. All right, everyone, and we're back with more fabulous prizes for you wonderful attendees. So we've just finished giving out four ROI training certificates. And now, because ROI was really generous, we're going to give out 10 $50 Google Play gift cards. That's right, 10 Google Play gift cards. And the first Google Play gift card winner is again, I'm not going to try to butcher your name, but you just won a Google Play gift card. All right, and now our second Google Play gift card goes out to Adam. Adam, you are winning a Google Play gift card. Now, our third Google Play gift card, brought to you by ROI Training. Ahmed, I'm hearing that someone has won twice. Ahmed? Hold on. We have to figure out that someone twice. So, Kagas, I am being told that you have already won, so unfortunately you're not eligible to win again. So that means we have another gift card to give out. So Adam, Ahmed, you're still good. Spinning for another $50 gift card, brought to you by ROI Training. Stephanie, you're winning a gift card, assuming that no one tells me that things went wrong. All right, now to give out our fourth $50 gift card, brought to you by ROI Training. Zoe, you are winning a $50 gift card. You got four. All right, and now give out our fifth ROI Training gift card. Now, these are Google Play gift cards, not gift cards to ROI Training. That was a different raffle. Mark. All right, just give us a moment, everyone, while we get the ROI stuff mostly settled, and we'll keep on going. You know what? We've been giving out gift cards for a while now. I think everyone's a little tired of gift cards. So why don't we move on to Dan Sullivan? So Dan Sullivan has graciously donated several of his courses to someone here in chat today. So we're going to start off. We have 3 associate cloud engineer and 3 professional data engineer courses. For the first associate cloud engineer course, we are going to spin the wheel for so dear Rao. I need to check that name. I think you already won something. You did, Sudhir. You have already won ROI training, so unfortunately you're not eligible to win again. So again, this is for our first of Dan Sullivan's courses. Mihai. You have won Dan Sullivan, one of his courses. We are offering 2 of the courses. You are winning a associate cloud engineer course. Congratulations. And now for the second associate cloud engineer course in the raffle. Hendrik Beck. Beck, let's double check. You haven't won something already. You have not. So you are winning one of Dan Sullivan's courses. You're winning the cloud one. Cloud associate. All right. And now for our final associate cloud engineering course from Dan Sullivan. Gabriel, didn't you already win something? I think you did. Let's double check that. Gabriel, you already won a O'Reilly book. So unfortunately, you cannot win more than 1 book with us. So I'm going to have to spin again. And Karen, you won something already. Thank God, you have not won anything yet. So guess what? You are getting a Dan Sullivan training course. All right. So we're going to take a quick break while we confer with Backstage.
Can everybody hear us?
Well, I guess choosing technical difficulties as a phrase for today was a good idea. All right, and we are back. You may not see your name on the page, everyone, because it's we have, as of last count, 115 people in the raffle, and well, that's a lot of people. All right, so now for our second Dan Sullivan data engineering course, the winner is Imran. Imran, you are a winner, assuming you haven't won anything else already. You have not. Just copy your name down. All right. Now for our final Dan Sullivan course. Clem Allison, you are getting a Dan Sullivan course. All right. And so that concludes all of the wonderful gifts from Dan Sullivan that we got. Thank you, Dan, for donating those for our DevFest. It was really nice of you. And now on to Wellframe. Wellframe has a $50 Amazon gift card for our raffle today. Only the one, but that doesn't really matter. All right. So this is for the Wellframe $50 Amazon gift card. Spinning the wheel, spinning the wheel. Omar, double check to make sure you are not winning twice. You are not. So guess what, man? You are getting a gift card. It's Fly to Save by Wellframe. All right, we're going to take a quick 30-second break while I confer with people backstage, and then we'll move on to JetBrains. All right, I'm being told from people behind the curtains that I actually have 2 more gift cards to give out from Wellframe. That's right, 2 more Wellframe $50 Amazon gift cards. So let's see who wins those. Who wins? Polarization's hard. All right, and the second of the Wellframe cards is going to go to all right, we're just going to check to make sure, man. You have not won it. So you're getting a Wellframe card. Congratulations. I'm going to spell your name because it's about as complicated as my last name. Anjaneya. You have won a $50 Wellframe Amazon gift card. Terms apply, all that standard stuff you're seeing. Now the final Wellframe gift card. It means, Sage, haven't you already won something? No, actually, you have not. All right. And that concludes our Wellframe gift cards. We're going to take another 30-second break while we confer backstage and then start into JetBrains. All right, everybody, and we're back. Sorry about that little delay. Just making sure that we actually can give out what we say we can give out, or that we have enough stuff to give out, because that could always be a problem. All right then. So now we have 3 JetBrains license keys, 1-year subscriptions to one of their products to give out right now. So the first of our JetBrains licenses is going to Danielle. Danielle, we're going to just confirm to make sure you haven't already won something, because so you have not, Danielle. So you are taking and getting a JetBrains license key. You will be getting that via email. All right, now for our second JetBrains licensing key. Jay Burnett, you are assuming you have not won something else. You have not. You are getting a JetBrains licensing key. Now for our third and final JetBrains licensing key. Okay, I thought you already won something. You have not. Congratulations. Didn't you win something from Practicum? You did. You won already from data analysis from Practicum. So you, unfortunately, are not eligible for JetBrains. I'm going to spin the wheel yet again. Spin, spin, spin on magical wheel. Jared, you already won something. You already won some wonderful ROI training. You can't win things twice. And so you are winning a JetBrains licensing key. That's 1-year licensing. All right, everyone, we're going to take another quick break while we confer backstage and then move on to the next giveaway. All right, everyone. So we're coming up on the end of our raffle, and the end of our time together. So we are now going to give out two $50 Amazon gift cards from Gaspacio. They were fine enough to give us some stuff to give out for today. All right, and the first person to win a Gaspacio $50 Amazon gift card is Alan. Alan, you have not won anything yet, so you're getting a Gaspacio Amazon gift card. All right, and for the final Gaspacio Amazon gift card, you have not won anything yet, so you're getting an Amazon gift card as well. All right, we're going to go on one little break and see what's left, and then, well, that will be that, as they say. All right, everyone. So we were talking backstage, and I do believe that is the total of what we're giving out today. Again, thank you, everyone, for showing up for DevFest Northeast 2020. Yeah, we had some technical difficulties, but I think overall we had some really great speakers today with some really great information. You will be getting a form in your emails, hopefully later today, tomorrow, sometime like that, asking you to give us some feedback. Please give us your unbridled feedback. We want to know exactly what we can change for next time and make sure that things are always awesome. I hope everyone has a wonderful day. Enjoys the full moon tonight, which is fairly auspicious considering the date. And stay safe out there. The world's a crazy place.